one of the main talks, one of the talks that changed my mindset, because again, I came from a developer background. I went towards infrastructure, then the switch to security. I saw this talk by Ben Hall of Katacoda and Andrew Martin of Control Plane and this company. And they are on stage and they were just attacking and defending red team. So they are attacking as a red team. Andy was attacking some hosting that Ben had. And Ben was the blue team. He was defending. I'll share a link to that talk. But seeing it was just so much fun. I didn't have a clue what was going on the screen. And so I'm hoping to give a couple of demos to that. So since then, I've joined Control Plane. We host these CTF events. But for me, I'm the head of training here at Control Plane. So for me, this aspect is that how can I learn from these CTFs? So I've SSH'd onto a box somewhere in the cloud, and then again, and if I'm going a bit too fast, this one's just a warm up, but this is just to show some of the things that made me interested in this. So I'm connected onto a box at the moment, and I don't really know where I am in the cloud. I just know I'm not on my machine. I can take some information from here. So this bit here, hashtag with this and that suggests to me that I'm in a container within a pod that's running on Kubernetes. I'm taking this deployment called hashtag. I can see the replica set here of hashtag 5D47, and this bit on the end, that's just random. So I'm taking some information from here. Now, having a look around, I can look at the environment variables, and looking at these environment variables is telling me that it's running on Kubernetes. I can see a Kubernetes port. Well, I'm assuming, unless someone's been absolutely horrendous and put all these environment variables to make me think I'm in Kubernetes, I'm starting to look at this and thinking what's going on here. I can also have a look around and I can look at the file system, and I can see here, again, if you run a container locally, this is a little bit of interest to me because I don't necessarily see this all the time. Incidentally, XVDA1, it's created utilizing the Zen hypervisor. So in this instance, I can start to figure out, okay, well, I'm in the cloud, I'm on a virtual machine that's running a container. Now, we've put some misconfigurations in here. So what I can do with this is that I can mount it in. So just to say, if you're new to Linux, a mount, when you have that beauty of just putting a USB stick and then it just connects automatically onto your operating system and then you can access the file system, within Linux, it's a little bit different. We need to mount it in. We need to say, here's this disk. I want to be able to access it. So just to show what I mean by that, if I list the mount, there's nothing in there at this moment in time. But then if I mount the dev XVDA1, and then I'll put that onto mount, I go back to my command and list mount, all of a sudden it's changed. And so what I've proverbially done here is that I've taken the root file system of a virtual machine that's running this container, and I've made it available within my container. So this is allowing me to escalate out of my container. So this is just like this is back to security principles now. Within the container, and containers, we use them for sandboxing. We think about that for isolation. We want to be able to run these things securely and next to each other. But because I had this file system mounted in, that's from the machine that's running this container, I'm able to get out of it. Now, I can also just go a little bit further into here to show what an attacker might do is that they might go to the root directory. And if I do a list -LA, it's showing me all the files. I wasn't expecting that. Again, I think this is my jet lag now hit me. I know what I've just done there. I'm not actually in my mount. Sorry about this.
Well, it was like Spider-Man's uncle that said, with great powers comes lots of typing. Right? I think that's the Linux principle.
Well, over the last 2 years as well, apparently I like to buy lots of different keyboards with several different layouts, and occasionally my hands just decide to go to a different layout.
What's your position on a separate number pad? Is that a good or a bad thing?
I'm off on number pads. That's not for me at this moment. But saying that now you've put that in the back of my mind. That's going to develop, and then before you know it, by the end of the year, I'll have several with number pads.
Very good, very good.
It's such an influencer coat, and so my confusion there was that I was going to root within the container. But if we look at my path here, I'm now within mount root. So this means I'm en route on the virtual machine. If I do an LSLA, I can see that I've got SSH in there. So if I go to that directory, and I can have a look at the authorized keys that we have available in here. Now, authorized keys, so if you use SSH, if you're using username and password, that's not secure enough. So what you can do is that you can use a public key, you can provide that to a machine, and then as long as you've got your private key, you can connect on via SSH. And so that's what our attacker has done in this instance. I know there's lots of text on this, but here we've got a piratical note to self. Don't misplace this flag. Yours truly, Captain Hashtag. So Captain Hashtag for us in Control Plane is our arch nemesis. There's lots of references to him in our book Hacking Kubernetes, and there's lots of art that we have there. But this was just our warm. This was me just to show quite quickly. I could have done this within 2 lines of code to show how, if we've got a misconfigured container, then an attacker who can potentially be on a shell within there, they can gain access to your virtual machine, your file system, and yeah. And at this point, I've become root of this virtual machine, which what that means is that the world is my oyster within this machine now. I can start running things. So I could do a denial of wallet attack, which means going back to 2018 and run more Bitcoin. What else could I do? I could run other container workloads, or I could start sniffing around for secrets. Because I'm root, containers are just processes. So I talked about this, what we think of for having isolation. But at this point, if I've got the privileges on this machine to be able to see everything that's running on it, I can have a look and see what else is running on here. So that's some of the things. But anyway, this was like our warm-up. I've got the next scenario I'm really excited to show you, because you might be saying to myself, well, yeah, I'm secure with this because actually for me to connect onto this, I require these credentials. So it's like, as long as I don't give some of my credentials, then this doesn't happen. So on my next scenario, we're going to hack into an actual website that's available on the public web. If you want to try and hack along, please try. And please, yeah, be kind, but tell me how you've got on. But I've got this website here. Hopefully
now, if I could interject, I think if people are doing this, they're not hacking, they're researching, right? I've never really understood the term, but it's research you could start doing.
You always need to ask for consent of whoever's owning this. So, but then this is, it can be scary at times. It can be like, right, am I doing the right thing? Am I getting myself into more danger and so forth? But then that's what we do here is that we like to spin up misconfigured things so we can create a safe environment for people to learn these techniques. And the reason is I don't want you to become an elite hacker. It's more of a basis of, if I'm given a talk about talking about how to defend your infrastructure, how do you do best practices? Why should you focus on security? I can talk for days and days and days, but instead, if I just show you how to do it, then it's just like, oh, it's that simple, is it? Okay, maybe I should change that. Incidentally, in that last scenario, we were running a privileged container. Now, if a privileged container is run by just passing through a privileged flag when you start up that container, the privilege is saying that this container is essentially root of a machine that it's running on. You might do that if you're trying to connect onto a device. Say that you got a GPU hardware on the virtual machine and you want to access that within the container. You might use that. If you wanted, you might think, well, I'll use privileged. If you wanted to access ports such as port 80, port 443 on the machine that's running the container, well, that is a valuable port range, so that's denied by default. But then you can use privilege to get past that. But the point here is that with most things within our industry, we talk about least privilege. That's the position that we want to go from. So you want to remove all these capabilities, and then you just want to assign it accordingly. And within Linux, it's about capabilities. We deny everything, but then we allow capabilities to these processes. So if you did need to access something, you give it a capability. And I won't go too much into detail with that. If you are interested, if you're like, well, please tell me more, reach out to me. I'm here in Omaha. I can respond to any questions that you may have. But so yes, hopefully you can see my screen now. The last time I saw Amy Kappas from Australia, she was teaching me a lot about front-end web design. I think she likes it. I think she would be happy with what I've got here. So I've got this website that's available on this URL. Now I think it's got username and password blocked on, so hopefully you can't get past that. But here I've got the memory CI/CD build system. Again, this is just that website I created it, and obviously where experiences become memories. Again, you don't need flashy things. You just need good wording. That's all you need. So if we have a look at build status, now you can tell that I've built this because it's currently down. My code quality, as you can see, isn't great, but so something's not going right on our system. But if I also have a look around on this website, I can see utilities. So it looks like I've been a bit friendly to our support team, and I've given them some tools that they can use, such as to be able to ping an IP address. So let's go ahead and try one. an IP address just to see if this functionality is working. Okay, that's a little bit funky there. I don't know if you saw that. I can see that ping is working. But when I typed 1.1.1.1, it's appended that with ping-c3. So this is leading me to believe actually what's happened here is it's sending this request across to the server. And it's not just passing through the IP address, but it's passing through the whole command. So this has piqued my interest. How can I take advantage of this? Well, one element of this design that I didn't mention is, oh, wrong window. Let's get on the right window there. I can pull up the developer tools. So let's go through this again. And we'll watch the network this time. So we'll ping 1.1.1.1, and we'll submit this. Now I can see that it's running on PHP. Again, .NET conference from PHP. Cool, thumbs up. What I can do here is that I can right-click, copy, and I can copy the request as curl. Now, the reason I want to use curl is because I want to come back to this screen here, and this is my playground. This is my terminal. Now, if I just paste this in, there's a hell of a lot of information in there. But if I hit enter, I can see that this has made a HTTP request, and I've got the response, and I've got this available within my terminal. Now, there is a lot of text here, and we'll look at tidying up. But here, one sec. Much information. I'm going to have to go down a little bit just to fit this all in for a moment. Go onto the line. So here's this bit of interest to me. Because that was a command that was appended to it. So it's not, the server's not receiving the IP address, it's receiving the request as well to run ping. So what I'm doing is I'm replacing that, and I'm going to use who am I. And this is what I find really useful, because days like today when I'm absolutely shattered, I just type who am I, and my terminal reminds me that I'm Lewis. But here we can see in the response from HTTP, we get response of Nginx. So being able to run, because I've changed that request now from that ping command, ping 1.1.1.1, because that's been changed to who am I, I'm now able to get some information back to say that this is running as Nginx. Now I could also change this, because I could change this to list. So I could have a look at the file system available at this point. There we go, thank you, internet. And I can see that we got the diagnostics PHP, I've got the index.html, and I got status.php. So I'm starting to take some information. Now, I'm not going to stay here all day just appending text to this. I think we can do one better. Like this is, we want to do stretch goals here. So what I'm going to do, first of all, I'm going to make this a little bit nicer for us. So we're going to do a little bit of bash. So I'm just going to change this to double quotes, and I'm going to pass through $1. Now that $1, that will utilize a parameter on our command line. So now we're just preparing just to get our attack all ready. So we're going to build out a function. So if I type function exec brackets, and so we're going to build out a function. Now this is my favorite bit of bash. These the bang bang. This will replace the bang bang or the 2 exclamation marks with my previous command that I ran. So we're preparing this function, and there we go. So it's prepared this function for us. So why did I do that? Well, now all I have to do is, if I type exec who am I, it's going to replace the $1 with who am I. So now I can just run exec ls, and then I can see that file system. I can run exec pwd, and I can see where I am. So I'm within the var www.html directory within wherever this is running. Now that's a lot better than having to do that curl request each time and having to amend that. But again, we can do one better.
You've improved the usability of it.
Yeah. Well, that's the thing. I need help with my usability. So much so that actually 5 minutes before this started, my webcam didn't want to start, so I had to restart. So now all of a sudden, I'm having to show behind the scenes as I prepare for this. So I'm going to use a number of tools here. So there's a tool called Penelope, and Penelope is a reverse shell. Right, I've just also realized that I'm going to have to share some details. Oh, actually, no, I had it hidden away here. Yes, there I had it. So I'm using a tool called Penelope. Penelope is a reverse shell catcher. So what that means is that I can send requests to an IP address on my laptop, and then that will hold it, and I'll be able to use it as if it's my own terminal. Now, the problem that I've alluded to, and if you've done your OSINT on this webinar or this talk so far, you'll realize that I'm in a hotel in Omaha, so I don't really have the IP address, and I think there's some firewalls in place that's going to block me from being able to use one here. So I'm going to be using a tool called ngrok. So ngrok allows me to have a public IP address, and then it's going to route it via its client onto my local machine. So I've already got this set up with my authentication. So if I run ngrok, we can see here it's giving me this public DNS record of 6.tcp.ngrok.io, and it's giving me a port of 12630. So anything that lands on that is going to be directed to my local host on port 31337. So let's pull up another screen here. I'll use this one instead. And so I'm just going to, so I need to set up my reverse shell. So let's just go GitHub Penelope. So here's Penelope. Now, for Penelope, I need to run, let's see if I did this earlier on. Yes, there we go. So I'm just running, it's a Python application, and I'm just running with port 31337. So now you can see that it's listening for reverse shells. So let's try and get this all set up correctly now. He said, oh, my hands are so jittery right now. I've had so much coffee this morning, and it's still not even 7 a.m. here. Right, so on this top line here, I've got my exec, so I've got that command there. I've got ngrok in the middle running, so that's receiving any requests on a public IP address. And then at the bottom here, I've got Penelope, and that's just listening for a request. So let's try and get this all set up and run. So if I take my ngrok, well, let's line up the attack. So I'm going to run exec, and then we're going to use ncat. So ncat's going to try and send us across the shell. So I want to use -v, -n, then I want to use this. Again, I don't trust my typing right now. And I want to put this onto port 12630. Cool, I think we're all good there to go. So let's hit that function and let's just see what's happened there. So I can see that I've got an ncat response, so it's ncat version 7.91 on the system. It could not resolve the host name. So we got a bit of a DNS issue here. Everything's a DNS issue, isn't it? It's yeah, oh geez. So how can we fix this bit? Well, what we can do is that we can use a tool such as dig, and we can dig to find the IP address that this is pointing towards.
That's a fun one.
Yeah, so now that we've done that, we can then just replace this DNS record with its IP address, so it doesn't have to look for that. And then hopefully, let's see what happens. So did you see that on the bottom of the screen for a moment? It was, so Penelope caught this request, and now it says I'm on bash 5.1. Also, love Penelope. Any CLI that can give me emojis, yeah, I'll jump through flames for. So now if let's just do the ones that I did before. If I run who am I, I'm now nginx. If I run list, I can see I got a diagnostics.php, I've got index.html, and I got a status.php. I can check the environment variables. But this is all a lot nicer for me, because now it's a case of, it's giving me that experience of I'm just feeling like I'm using my own machine. So this is the first phase of the attack. This is us gaining access to a terminal, to a prompt on another computer somewhere else. If you see these invalid shells, it's just because the IP address is being scanned by someone else somewhere in the world right now. So that's just going to pop up occasionally. But so that's our first phase of attack. We've got onto this system, and we've been able to do that because we've had a vulnerability on our website, because we didn't follow best practices. As I'm sure people are saying, why would you send ping 1.1.1.1 to an endpoint? And then, well, that's because looking at OWASP, look at those securities, listen to everyone in the industry, don't do that. If we pass through the parameter, if we just pass through 1.1.1.1, this would have prevented this at this stage, potentially. Cool. So now let's go back towards Kubernetes, if I may, for a moment. I'm kind of giving away as to where this is running, because this is running on a cluster, but I can't see it from there. But we can start having a look around. So we can have a look at the processes running within here. So I can see that nginx is running as process ID 1. So that's the main process that we have running here. And so we can see some PHP running. Incidentally, we can see the ncat command that we ran to be able to spin up this reverse shell. We can see the shell that we're connected to there. Oh, so we're connected to bash here, and we just ran psorgs. So not too much there of interest to me at this moment. Maybe let's have a look at the disks. So again, looking at this disk, I can see here that there's a number of things. Dev XVDA1, we saw that earlier on in the demo, but I'm interested about this temp FS as well. So I can see here that I've got a Kubernetes service account on the temporary file system within this, well, I think now is a container because it's running on Kubernetes and Kubernetes would run containers. And I've also got this run emotional status. So let's have a look at run emotional status. Let's go run emotional status. So if you have a look in here, I've got current within my emotional statuses. And I can see that my emotional statuses are anger, fear, and disgust. So at this moment in time, does anyone have an idea what this could be relating to? And this isn't to do with technology. This is more to do with movies, because when we ran this, we ran this as a CTF at KubeCon in LA. So we had a bit of a Hollywood theme. So we based this on movies. And so, so I found this because I wasn't expecting to see, if I ran DF, not expecting to see run emotional status. Emotional status isn't something that we usually program into our applications. Incidentally, though, mental health is a really important thing. I've suffered from it. So if you're suffering, look for help. But this, anyway, that's another thing for another day. At the moment, if I look at current again, so I've got these emotions. Now, these emotions are linked to a movie called Inside Out. I hope you've seen Inside Out because it's phenomenal. It's great. But there are 5 emotions that we have, and we've only got 3 here. We've got anger, fear, and disgust. Again, I can relate. So what we might want to do is, because let's relate this back to the website for a moment. It's missing a couple of emotions. So maybe those emotions, those missing emotions are why our build system might be potentially down. Let's try and update our emotional set. So let's have a look. I'm going to go into Vim for a moment, and we're going to have a look at current. And so there, I can see the file. So let's just add joy and sadness. Let's bring joy. Let's Marie Kondo this file. So, okay, I can't write because it's read only. So I can't write to this file. Okay, why can't I write to this file? Well, again, behind the curtains here, this is a config map. This is something that we store within Kubernetes. And so this is some state that we want to put into the container when we run it. Now, one of the engineering principles of it is that we want this to be read-only. So when this is within a container, we're not expecting for someone to come into our container and update the file to be able to say joy and sadness. That isn't what we want to do. And so that's why I can't write to that. So now we need to look at biting the hand that feeds a little bit. Maybe we need to look at utilizing Kubernetes. So let's see if we've got kubectl available. So kubectl, and as a number of people will call it, kubectl, kubectl, kubectl. This is a tool that we use to connect to Kubernetes. So I can see that I got kubectl, so I'm just going to do kubectl get pods. And so this is just showing me that I've got working, what I've got available, but it says that the connection's not available. And I'll just check here. If I do kubectl version, I can see that the local version I've got is 1.22, but it can't connect onto a cluster at this moment. Now it can't connect onto the cluster because it doesn't have any credentials. So, but let's go back a step if we may. If we look here, we had this run secrets kubernetes.io service account. So let's have a look in there. Run secrets kubernetes.io service account. Incidentally, at this moment in time, I'd just like to say this is why I love Penelope, because if I had to do this via a curl request, then this is going to take me a lot longer. If I do an ls, I can see in there I've got a cert, I've got a namespace, and I got a token. So let's have a quick look at that token. Now that looks like a job to me, which is good times. This is something that I can use to connect to a cluster to. Now, incidentally, when we run Kubernetes, when we run containers, a service account will be placed in a container, and by default, it's going to have least privilege. It's not going to be able to do anything. There's a reason for that. There's a reason why it might be there, because it can also give us it can give us confirmation as to what container this is, because if we're talking about Kubernetes, we're talking about running at scale. But let's see if we can utilize this token. So at this point, and again, I'm just going to relate this back to my jittery hands. I'm going to try and do a copy and paste. Yes. So let's just see what this copy and paste accomplished. We've got kubectl. This time we're identifying the server. kubernetes.default.svc cluster.local. Kubernetes manages its own network, so it's got its own DNS. So that will resolve internally within this cluster. And that is by default where I'd expect the cluster API to be. Then I'm passing through the token. And so to pass through this token, we're just going to cat out this service account to that. And finally, we're just running insecure skip TLS verify, because I'm just going to assume we're not, I was going to say we're not in Omaha anymore. I think it's another, we're not in Kansas anymore. Well, we'll see, we're not in Omaha anymore. Right. So yeah, we don't have as much of a nice experience with kubectl at this point, but we're going to run version. So if I run that, and I'll clean up my screen again. There we go. This time we can see that we've connected onto the server. So because we've utilized that service account and we've used that token, it's now given us access to the Kubernetes API server. So let's just, like earlier on, I just did kubectl get pods. But I can't do that again. I need to replay this one. So I need to just keep passing through that setup that I have there. I'm getting a different error this time, but this is an error response from the server to say I'm forbidden, pod is forbidden. So this user within a service account cannot list resource pods. So this is something called RBAC. So this is what we utilize within Kubernetes to give permission for identities to be able to access things. And so in this instance, I can't access pods. Now, there's a great little command, and I'd like to reference Duffy for this one. Duffy is, he works at a company called Isovalent now, and he's just a phenomenal knowledge base. And so shared this one with me. So if I run kubectl of can-i -list, I need to zoom out a little bit for that. Zoom back in. So if I run this, this is just telling me everything that I can and can't do within this Kubernetes cluster. Ian Coldwater, they say we're all made of stars, but your RBAC shouldn't be. That references that if you've all got stars, you're cluster admin. And again, that's giving you like the keys to the castle. So we got good RBAC principles here. But there must be something else that we can do. And again, this is where we're going to utilize just looking around our cluster a little bit more. So if we go back to this Kubernetes directory that's being applied to it by Kubernetes, we can see within our service account, we've also got a namespace. So let's see what that namespace is. And this is, the namespace is called CI memories. Now, namespaces within Kubernetes is kind of like a virtual cluster. Namespaces give that isolation. It's what we think for multi-tenancy, so that we can say, here's a namespace for dev, here's a namespace for prod. Again, there's so much material that they're not isolated at all. It's just like giving people areas to play in, but everything can communicate to each other. You can harden them, but that's another thing for another talk. Now, the point that I'm saying this is that what I can do is that if, let me just see, is that the right one? Okay. Someone's now found this IP address and is pinging the hell out of it right now. So what I can do is I can pass through a namespace CI-memories. And I can see from here that this time I can see for config maps, I can get list, patch, and update them. So this is, so that's giving me a little bit of information as to, right, okay, let us have a look at if we can see our config maps within this namespace. So get config maps, so I can see if the emotions are there. So let me just, I've pressed up twice because my hands are going crazy. So if I get emotions and I can output this as YAML within the line, I can see that here, this is the data that's been set into that emotional status current file is anger, disgust, fear. So let's use Kubernetes then to be able to update our file for us. So if I edit this, and then I go down to our current emotions, joy, sadness, and also I'm going to update it down here as well, just because. So I should just be able to update the top, but I'm going to just update it there. Okay, cool.
You don't want to increase the version? This seems like an improvement.
Oh, I told you I'm terrible at coding. I should, well, yeah, it's when I hack people, I try to do their code reviews at the same time and just go like, yes. So if in doing that, let's see where we are. We're currently here. So let's go back to our emotional status for a moment. Let's cut out current. Okay, cool. So it's now changed to joy and sadness. So what we've done is, again, back to like the hand that feeds talk, because we didn't have the ability to be able to change this file because I had only read-only permissions here, we had to look at our service account, and then we had the service account, and to begin with, it said you can't do anything, and that's because it was trying to utilize the default namespace that we provided it, where it can't do anything because of a while back. We had a little bit of a look into it, and then we figured out, well, actually, we can have a look at another namespace, CI memories. So running that command, we could find that we could get list, patch, and update config maps in the CI memories namespace. We did so, and that updated our file. Now, if we go back to our lovely dashboard here, and if I refresh it, I can now see that we've done something anyway. So our machine is now clunking away, and it is now running perfectly balanced and running properly. All our sockets are neatly aligned. So what have we done so far? We've come to this website. We've had a look at this website, and we found that we had a vulnerability here in utilities. We sent a ping request, and then looking at this ping request, we saw that it prepended ping -c3 1.1.1.1. We looked in our network tools, and then we looked at this request. And then we copied it as call for us to be able to go to our terminal. It's on this one. But again, because as you can see from this right now, I'm all about making my life as easy as possible, because apparently everything is on fire with me most of the time, including this shell being disconnected. Now, the shell being disconnected, it isn't the end of days. We can just reconnect. So if I go back up to my top shell here, where I've got my payload set up, so if I run that again, you can see down here back on Penelope, it's now got a new session, session 2. So if I type session 2, there we go. Now I've connected onto a session. So I've reconnected back onto this host. Now, how we're doing on time? We've got about 10 minutes left, I think.
Now, how could the state of the world come to be that your original problem arose? Did someone just forget to scan out for some commands there, or what's the part of the story where all of a sudden you can start messing around with stuff?
Great question. There's a number of levels. This could be just a developer not following best practices. As we saw, we're passing through parameters there. We shouldn't be doing that with our endpoints. And back when I was a developer, I remembered that we shouldn't add functionality like this to be able to say, run this command from this website by hitting this endpoint. So that's one thing that we can follow best practices. Again, OWASP, look at the top 10. And that's the thing, security isn't challenging to defend usually. It's the 80-20 principle. The things that you can do really quickly are going to cover 80% of the instances, issues that you have. Then you can focus on that 20% and harden again and again. But then that's just developer mispractice. It could also be a supply chain issue. So it could be that there's an exploit available within some dependencies that you have. And so there's been some in Nginx, and this is a thing, I need to be careful, because I don't want to sound like I'm hating on people writing new code. I'll always prefer people writing new code than having to use old code. And equally, I understand, as a developer, we're into time constraints. It's we need this done by now. And so sometimes the decision that you make at that moment in time, something might go wrong, but then this is where having good CI/CD in place allows us as well. We should also be, within our CI/CD pipelines, we should be testing for our security. And equally, if we're in this position where we can constantly run CI/CD and we can deploy at any moment, if we do find that we've got a supply chain exploit, so find that because we're dependent on this library that's now been now that it's so we're inheriting something that has an exploit within it, then we could look at patching that and being able to release. But if you've got, let's say, a 3-month cycle, again, back when I was a developer, I worked at a place where it took 3 months to roll out new code. When you've got a 0-day that you find out, when you find out that actually we found this exploit, if you've got a 3-month release window, you've got an exploit for 3 months, that's not going to be best. So I hope that answers that bit.
Yeah, for sure.
Cool. Again, I can go into some more details. And equally, I'm trying to remember the question because my memory is completely shot right now. And I did say shot.
That's why you have this cluster to store all your CI memories, as I recall, right? And if only were as easy as just entering a kubectl command to change your emotional state. That would be exciting or scary. I wonder what, who knows what people would do.
Well, I am looking for some VC backing for my company that will allow this to happen. So I will look at managing emotional states by config maps. Yeah, no, it's oh God, that would be good. But yeah, I'll save that. I'll save that one for another day. But there's another thing that's happened here, and it's back to here. So when we had a look at this website, and we had some information, build status, that this changed, and we got all sockets are now neatly aligned. Now, what we used to see within CI/CD is that when you need to build containers, you might pass through the Docker socket into your build pipeline to be able to build these containers, because it's like I like to think of Kubernetes as Mr. Meeseeks from Rick and Morty. In the episode where Mr. Meeseeks discovered Meeseeks box and just keeps smashing and loads more Meeseeks appear, to me that's Kubernetes. It's containers running containers. So sometimes we find within our pipelines that Docker socket was available. Nowadays there's tools like Canico and Tecton where you don't need to have access to a socket to be able to build containers. But anyway, for now, that's what used to happen. And if we got this information to say a socket is running, maybe we should have a look for the socket. So if I run df, now back here, we can see where we had our Kubernetes service account and we've got our emotional status. Now we can see that we've got run sock.docker. Incidentally, someone's been clever enough to swap this around. Normally you do expect to see docker.sock, but we got run/sock.docker. And that's something new since we fixed our system. So how can we utilize this? Well, we can use Docker. So let's just see if we've got Docker available. And instead, this is why you don't want to ship any CLIs into your images. Like if you're going into production, you don't even want to have bash and shell in there. You want to utilize scratch images. Look towards them. I can point to more resources. If this is like tingling some of your like spidey senses, going like, oh, I think we might have a problem here, just drop me a DM on Twitter or something, and then I'm happy to give more insight into what you can do to prevent this. Distroless is what I'm pointing to for your base images that give you Scratch-esque images. Right, and so we've got the Docker CLI available. So we can, if I do Docker PS, it's going to say cannot connect to the Docker daemon at var run docker sock because it's no longer docker sock, it's sock.docker. So I'm just going to copy and paste this again. So instead, I'm just saying that our Docker socket is located there. So if I do Docker PS, then all of a sudden I can see all the containers that are running on this machine. We can also see our restart that happened 6 minutes ago because this is a container that we're running within. So now it's Mr. Meeseeks time. Now, if you remember when we did this warm-up this morning, when I did this quick introduction just to say, here's a privileged container, and this is like, privileged containers, sometimes people have used them in the past to be able to reset their password as root. If they're the administrator of a machine and they've lost their password, run a container as a privileged, run a privileged container, you can change your password back, you can set up a new user. So maybe that's what we can do here, because we've got access to a Docker socket. We could run another image, and so we're going to run Docker run. We're using our Docker socket. This time, here's a privileged flag that I said is the most dangerous flag. Well, actually, Andrew Martin said this is the most dangerous flag in compute because it removes all the isolation. And so Justin Cormack, who is now the CTO of Docker, we're going to base this on an image that he has, which is nsenter. Now, what this means is that we're running a container. We're going to connect into it. And as you can see, my prompt has changed to a hash. Let's try it. There we go. So if I do ls, now I can see that I'm on another file system, and this time I've got VM liners. Now this suggests to me that I'm on the root file system of the virtual machine again. So at this point, we just have a look around. So if I check out root, and then finally I can find our flag. So this was where our flag was hidden all along. I won't share the flag for now because we still use these at conferences and so forth. Again, this is tools that we like to utilize to be able to show how to be able to attack systems and how to defend them. At this point, all this work that I've shown, this wasn't done by me. Well, I helped out, but there's one person, James Cleverly Prance, who works at Control Plane. Absolute phenomenal talent. Like we came up with these scenarios together, but he kept pushing it. So again, I think hopefully there's a Twitter link that's been referenced with him. If you've heard of Dirty Pipe, that was about a week old now, he's been doing some phenomenal work on that. So if you're interested in security, if you're interested in pen testing, red team. And also, if you like these CTFs, that's definitely someone that I would follow. Yeah, I guess at that point, I think we're almost at time. But if you do have any questions, I'm happy to answer them now. I'll bring up the screen actually.
Here, let me. We'll go back to just our two heads.
Oh, cool.
We could go to maximal two heads, but maybe minimal.
No, well, I found out that the chair's got quite a good bounce reflex as well to it, so I'm just enjoying this.
Of course. Well, if there's any questions in the audience, feel free to put them in the chat, and I will I will channel them in. I have a question though.
Yeah, yeah.
So I think. Let me see if I can make this state this question in an answerable way. But so, well, let's start it this way. What do you think when it comes to Kubernetes, insofar as you've been digging around in it? What are like some great things that it's done security wise to kind of prevent people from stumbling over their own shoelaces, right? Like, and I'll give you an example. What made me think of this is that like there is a certain amount of like you can't change the state of things built into Kubernetes, as you showed. When you can't change the state of things, you make tools so that you can change the state of things. But whatever, you've kind of like you've made it more complicated and more involved. But it's a good first move to say like maybe the core atomic unit shouldn't really be that changeable. But I'm curious, like, what you think other like improvements that Kubernetes have that are clever or just like nice.
Yeah, and again, straight up, I want to put the caveat in place. Like, the people who work on this are phenomenal and great engineers, and like have a rate of release, so it's released every 4 months, and the community that's behind it is great in what they do. And that's the thing, as we learn, as we evolve, and as more ideas come to the community, then we find there's different ways of being able to hack around with the cluster. For me, the exciting points are now container runtimes, because we're seeing from there's Kata containers, gvisor, Firecracker. This is all different ways that we can run containers. Containers are essentially just processes running on a system, and we want to isolate them as much as possible. And seeing these new developments, and equally, like I've mentioned Justin Cormack, who's now the CTO of Docker, I think for about a year now, like seeing the developments that the industry are doing there, that's awesome. When it comes to Kubernetes itself, again, it's this basic of, if you spin up a cluster, everything can talk to each other. So looking at network policies, and limiting what things can communicate with other things, and doing it as soon as possible, really, because I understand like sometimes security comes a couple of days after releasing something. But if we can start with least privilege, if we can start to then say, well, this pod can't communicate to this pod, or this pod can't communicate to the internet, that's something that we can put in place just to mitigate that. Also, security in depth. It's onion layer security. So you don't want to just have like a firewall on your machine and then say, well, if you break through the firewall, the world's your oyster. Sam Newman, who wrote Building Microservices, I saw a great quote from him, and it was based on castles. When you visit a castle, the layers of defense that you see in there at each hurdle, that's what you want to put in place. And maybe it's this mindset that you are going to get attacked, you are going to get hacked. And so if you've got a public-facing website, you have that in a very safe, secure place, and you don't have it on the same machine, say, as running your production database or something that has high value. Having that separation and these are just concepts where it's a case of, it's just best practices. And probably that's what Kubernetes is to an extent. It's just, it brings a number of people across the industry to a single point where there's lots of experience with lots of like battle-hardened vets, but equally new people as well who are coming out, and that allows us to put our best foot forward, and we can learn and essentially stand on the shoulders of giants. Like we can, whether it be networking, whether it be storage, whether it be apps, whatever API design, we're learning from the best. So.
You know, I think to play around with your metaphors and analogies and whatnots there, like it is, you know that the thing that I admire about Kubernetes is how it has finally gotten momentum around standardizing just core infrastructure concepps, including configuration, right? And you highlighted several of these, right, in what you're talking about, particularly like the concept of a namespace, and I guess you know with your giants thing, right? Like a lot of organizations try to like grow their own giants, but it's often helpful just to like use someone else's giant to sort of base your stuff on and stand on the shoulders of, which is I don't know, which is good. Now the other side of my question, not to make it too nefarious, is so like you've cataloged some of these things, but like if you were to name like one or two like fundamental shifts in thinking that a programmer or someone designing code should have for security in Kubernetes, like what's some major assumption or major way that you would be programming in, like, I don't know, just like more of a traditional way that you kind of change to make things more secure in Kubernetes? That's a bit of a broad question, but I'm sure there's a few things of like, oh, this thing that's totally cool to do over here, don't do that here, because that either makes security more difficult or it's an obvious like problem that you might have.
So, yeah, great question again. And I think Kubernetes is known for not being, well, and again, this is probably not fair to an extent, but some people say it's not developer friendly because there is a steep learning curve in aspects. Now, as an application developer, personally, I see the boundary between dev and infrastructure, or DevOps, or any of that is this container interface. If you can build the best app within the container, if you can follow the best practices, so if you can, for logging, for instance, if you use standard out and standard error, then Kubernetes can capture all these logs and then run for it for you. If you implement your own logging mechanism, then you need to build other things around that to then capture these logs. And in doing that adds another potential attack vector there. So that's one thing that I'd look at doing. Multi-stage builds as well. So if you, as a developer, you want to be able to debug. And so if something's not working in production, you want to be able to say, well, I can just jump in and use this tool. I could use Bash, I could use the shell, I can use this compiler, I can use something to be able to figure out what's going on. Have a mindset that if you're doing this with the best intentions, what would you also do with your worst intentions? What would you potentially do if you weren't too happy with your employer and so forth? There's actors in place within some organizations, dependent on size. If there's someone with another hidden motive, then it's a case of, as you saw today, I had access to a shell. If I didn't have access to Bash or shell within that container, I would have struggled. If I didn't have access to Netcat, I would have struggled. So it's focusing on just best developer practices, and don't feel that you need to know everything about Kubernetes. Like I said, if you can understand containers and look towards people, especially from .NET, Elton Stoneman. Like I learned so much from Elton, and he's such a lovely chap. And he's got a number of books, and it helps understand from containers to Windows containers to Linux containers, and that's definitely a really good place to get started.
You know, it sounds like, especially if you're in the .NET world, it's just sort of like, well, it helps to understand like the basics and intermediates of how Linux things work, so that you don't sort of like do some things that seem good that actually aren't bad in the intentions of how the system operates.
And yeah, but we've all got to learn by mistakes, and we celebrate our victories. Like if we make 99 mistakes and we just succeed once, and sometimes we focus on that. But again, like I said, for me with this was a big learning curve for me. I didn't know anything about Linux going into this a couple of years ago. And then I had to make some mistakes personally. I ran a cluster using Raspberry Pis. I won't be ashamed to say that I used a number of tools that we give to school kids to figure out how to use a Raspberry Pi. But then that's the thing. Don't waste your emotional energy on other things, such as, why don't I know this? Why can't I do this? Why am I doing that? Why am I using a kid's resource for an 8-year-old? It's more of a basis of look at what you're achieving. Look at how far you're pushing forward. And I guess that's from a .NET perspective, it's always, I look towards Azure as well. I remember like Visual Studio Code or Visual Studio, utilizing Azure, seeing everything happening there. Like Azure have Brendan Burns working there now, and Brendan Burns was one of the founders of Kubernetes. And looking at the amount of work and effort that Microsoft is putting into Kubernetes as well, within the open source, as well as their offerings, then for me, this is an investment. Like it is no longer is Kubernetes being used. It's there. And but finally, I guess it's back to the thing. As a developer, when I started doing this, it allowed me to focus on best practices again. It allowed me, it forced me to up my game a little bit as an application dev, where it's like, right, what are these best practices? I remember writing my own authentication server once. Never again. Don't. So maybe that's the last thing as well. Just when there is something that you can use, when things are difficult, they're difficult for a reason. You don't have to solve every problem. Just focus on the things that you can achieve.
I have some friends I, as they say, came up in programming with, and we used to always joke that you're very close to the apex of like beginning programmer absurdity when you implement your own authentication and authorization service. You're just like, we finally need some way to do permissions and logging people in. So I'm gonna implement that, and I think most every developer at some point ends up trying to program that system instead of using an off-the-shelf thing.
Yeah. I just hope that I hope that that system is dead now, because otherwise there's another CTF available somewhere else. But yeah, and again, if anyone's found this interesting, or if there's other points where it's like, what was that? Can you show me that? Just again, reach out to me. I'm more than happy to help out in any of these things. I stood on the shoulders of giants. I referenced Ben Hull and Andrew Martin as the two people who really showed me something which piqued my interest and made me focus on this. So anything that I can help out to do with anyone else, just give me a shout. And yeah.
Well, here, we've got another great talk that I'll get to hang out around coming up in just a few minutes here. But we've got a little bit longer. So if there's any questions in the chat, I'll answer them. But let me ask another like general question here, which you're evoking in my mind is like, maybe I'm totally wrong, but like security people always seem a little like cynical and dark, right? Like they're not sort of like the cheeriest group of people. But you strike me as someone who is pretty optimistic and cheery about things. And so when you're thinking about, oh, look, here's a way that I could bring down the global computer system if someone like allowed me to do something. What's the way you sort of like maintain this optimistic, even sort of playful approach to security? Because it seems like, you're always on the knife's edge of like, oh, I could introduce like a wormhole for Skynet to come in here. Or I could just sort of demonstrate how you should filter commands that get sent in better.
I think, yeah, again, great question. On the people side of things, I'd probably reference that it's the same with any conference that I go to. Whenever I meet people in person, any preconceived ideas that I've had for this person are dropped. It's like everything's so warming and welcoming within the community, and that's probably something that we've missed a little bit in person over the last couple of years, is because we're hidden behind the cameras. And equally, I understand that like it's really difficult to raise hands and so forth. So saying about the security community, I understand like it's that thing. It's like it's a way it's portrayed in the media. It's a way that it's dark hoodies in a corner, someone who's socially like anxious and so forth. But like at this conference, the people that I'm meeting are phenomenal. It's so much fun. And I think it's back to this thing about we're all there to solve problems. It's this case. This is just, in my mind, this is a game. This is a case of, right, it's playing chess or something. It's looking for that next point. It's looking for that next point to reach. And that's the mindset of it. If you overthink these things and try to figure out what you don't know, then you get stuck in a bit of a rut. I think that was the first bit of the question.
I don't remember the question either, so you're doing a good job.
But I think, and it's like, and I guess a lot of people within this industry come into this as a hobby. Like I remember when I was a kid, I had my first PC, and the first thing I was trying to do was like trying to see it, well, I could do, like get to our next bit and our next bit. And I guess that's an application dev at times. It's a hacky thing, isn't it? It's a case of I'm not necessarily doing best practices, but I can do it. And that's kind of like, that was shifted out of me a bit to say, don't do that. You need to follow these practices. I once got a slap on the wrist for a bank for using a secure USB device that you had to give a PIN for. And I just thought I had to spare 2 hours. So I created this huge directory of, don't go in here, there's nothing to see here. So you could just keep tabbing it. And it was essentially a story coming across, except it got caught by their security team. And then they came and asked me what the hell I was doing. And it was like, nothing. But my point here is that energy, like if you find these things interesting, don't necessarily do it on your day job. Don't do it on the thing that people are paying you for. Don't write your own authentication server. But at home, do it. Like, pull down this authentication server, look for CVEs, and that's like with what I've demonstrated to you today. We run this at KubeCon. There's a project called Simulator that's available, so you can run this locally on your machine that can spin up infrastructure for you to hack. But then that's the thing. There's nothing malicious in this. This for me is a puzzle in my mind. This is something that I'm trying to solve. So